Beer. Yeah. So today we start with this is day 4 for the training session in Lebanon. We're going to continue the procedure for analysis. Today it will be soluble chloride. Actually, it is not approved yet by NASOLAN, but soluble chloride is, we will going to use a recognized international methodology that adopted by United States Department of Agriculture. And for soluble chloride, normally it is measured in saturation extract that as prepared for the previous calcium, magnesium, and other anion. And its concentration in the extract is determined by titration against silver nitrate. So in this case, chloride will be precipitated as in a form of AgCl, or that silver chloride. Principle, although in the past tradition is that chloride is not considered as the essential micronutrient for higher plant, but there is new trend that chloride is essential in micronutrient, and it is very important for crop or plant in general growth. Chloride or chlorine, that is the inert form of it, come to the soil mainly from rainwater and from the sea spray and dust and air pollution. All this, they are sources for natural chloride in the soil. In addition, for that, human practices, including irrigation and fertilization, actually contributes very significantly in chloride deposition in the soil. Chloride is water soluble, so its movement, its soil profile is very dependent on the flow of water. Therefore, in case of human practices, in addition to the other natural conditions, the accumulation of chloride come to be in many places very high, and this is very toxic to plant. The pronounced feature of chloride that it has antagonistic effect on nitrate. So whenever there is chloride and nitrate in the soil, there will be mutual effect between them. So the uptake of chloride may influence the uptake of nitrate, and this is of course has a very pronounced effect on the crop growth. As you know, that nitrogen is a very important micronutrient that is very essential for plant growth. As I said, there is a paradigm shift that in the thinking of people, that chloride has changed from being considered a harmful ion to become a very essential in micronutrient. And this is, of course, come from some development of understanding of nitrate transporter in the plant, and it considered to be a very important, not only as a micro, also it comes as a beneficial macronutrient. Chloride have a very effect on the fresh and dry biomass. Also, it promotes the leaf expansion and elongation of leaf and root cells. and this improves the water relation of the plant. So the presence of chloride is very important for taking of water from the soil to inside plant cells. For determination of chloride in the soil, the sample preparation, like the previous one, air dried 2 millimeter sieved soil is suitable for determination of water soluble chloride. We move to the necessary reagent for determination of chloride. Basically, potassium chromate solution and silver nitrate. Potassium chromate solution, 5% in a water, and this can be prepared by dissolving 5 grams of potassium chromate in 50 ml distilled water, and add dropwise as indicator 1 N silver nitrate until a slight permanent red precipitate is formed. Then you can filter and bring to 100 ml volume with distilled water. For silver nitrate solution, 0.01 normality, just dry about 3 grams silver nitrate in an oven at 105 degrees Celsius for 2 hours. Cool in desiccator and store in a tightly stopped bottle. Dissolve 1.696 gram dried silver nitrate in distilled water and bring to 1 liter volume with distilled water. You can prepare standard solution of sodium chloride solution with normality 0.01, dissolve 0.585 gram dried sodium chloride in distilled water and bring the volume to 1 liter with distilled water. The procedure: take 5 to 10 ml of soil extraction into a wide mouth Brazilian crucible or 150 ml Erlenmeyer flask or canonical flask. Add an indicator, 10 drops of potassium chromate, and then titrate against silver nitrate solution until a permanent reddish brown color appears. Of course, you have to run a 2 plank containing all reagent, but without extract from the soil, and treat them in the same way as for the sample. So that when you come to the calculation, you will subtract the plank titration reading from the reading for all samples. The calculation will be chloride in milli equivalent per liter equal B minus B multiplied by N multiplied by R multiplied by 1000, and all of them, they are divided by the weight. Where if V is a volume of 0.01 normality silver nitrate titrated for the sample in millimeter. The B is the plank reading, titration volume also in the millimeter, and L is the ratio between total volume of extract and extract volume used for titration. This is especially if you have some dilution. N normality of silver nitrate, while the weight is abbreviated by WT, weight of air dry soil in grams. For process of standardization of silver nitrate, titrate 10 ml of or previously prepared sodium chloride solution with 0.01 normality. We take 10 ml against 0.01 normality silver nitrate. After adding of the indicator 4 drops of potassium chromate solution until a permanent reddish brown color appears. So that you calculate the normality of silver nitrate by equal normality of sodium chloride multiplied by volume used by silver nitrate. And this will provide the standard or the actual reading of your used solution of silver nitrate. Here is a reference. And this also, I think it is especially the second and third reference, they are considered to be further reading concerning about the importance of chloride as a beneficial macronutrient in higher plant. As I mentioned, in the past, there is a little concern about chloride as a micronutrient, or normally they think of it as a source of pollution rather than a source of important macronutrient or micronutrient for the plant. But now there is some changes in paradigm. There is no thinking that it is very important for the plant. We finish with chloride, and hopefully we can get discussion and also practical part from Abir, another colleague in SOR laboratory, I think. Thank you.
Thank you, Doctor. For the practical, actually, I did it yesterday because I have a problem of electricity and connection. So I can share it as PowerPoint, the result, the pictures of the results.
Okay, this is okay.
Okay.
Do I need to stop share my?
Yes. Just 1 minute, my laptop is slow. You can see my...
Yes.
Okay. So for the chlorine in soil, it's just some information. It was said by Dr. Muhammad. I will not repeat it, and also for the reference. For the practical, for the procedure, so first we weigh a mass of soil, seeped air dry soil of 2 millimeter size. Next, we go to prepare the soil extract by ratio of 1:5 by adding distilled water, and then we agitate for half hour. After that, we go for filtration of the soil extract solution. Sorry, here by mistake, I did prepare the ratio of 1:10 yesterday. After that, after filtration, we take 10 ml of the filtrate and we put it in a conical flask. Then we add 4 drops of potassium chromate solution. So the color of the soil filtrate became yellow. After that, we made the titration against silver nitrate solution. And for the result, we get the color reddish blue. And we compare it with the blank. And here the calculation.
Very nice presentation.
Thank you. So fast.
Thank you, Abir. Very clear and instructive.
Thank you.
I just want you to use maybe centimole instead of milligram equivalent.
Yes, I was thinking about it, but
the new unit. Okay.
yes, the unit. Yeah, it's better to be in.
No problem, but this does not undermine your effort. Thank you. Very well done.
Normally with titration with chloride, the color starts from the beginning, but it will not change completely to red. So
Yes.
yeah, so when you are doing titration for the other colleague, it is always important to think that it is not like the others when it is a start, but from the beginning there will be development of the color, but you will stop titration when the color is permanently.
Permanent.
Yeah, all the solution is changed.
Yeah, you are right, because directly after the first drops, it became
Red.
red.
Yeah.
That's why I repeated yesterday many times. I thought I had I problem.
يعني دي من التجارب المهمه في الكلورايد، لانه بيحصل بريسبيتيشن من اول دروب. فانت لو متعود على في الكيمستري لما يحصل تشينج في الكلر طوال انت يستوب التايتريشن، لكن في الكلورايد لانه هو بيحصل بريسبيتيشن فانت زي بتواصل لحد ما يحصل بريسبيتيشن لكل الكلورايد الموجود. ما من اول ظهور انت بتوقف المعايره يعني titration.
اوكي.
اي كومنت؟ هنا كومنت؟
Will I see some precipitate if I continue adding the silver nitrate?
I don't understand you well, Abir.
Sorry, I was asking if I will continue titration. and the color is permanent. After that, can I see precipitate in the flask?
Yes, in some cases, yes. When it is too much, you will see some development of precipitation at the bottom of the flask.
Okay.
Actually, if you dry the sample, the appropriate, you will get the
precipitate.
Precipitate, yeah. Silver chloride.
Okay.
Maybe this is the process of precipitation and evaporation to get precipitate is the principal method for the determination of sulfate in other the next presentation. That you make a precipitation, then you will start process of evaporation, or another way you can make separation between solvent and or solution and precipitate to get the salt itself, like we normally did in total dissolved salt. If you practice this, you make evaporation and then you will get the salt on the crucible or in the flask. You get my point?
Yes, I do. Thank you.
Welcome. Normally, also, if we come to the practical point of view, normally chloride, carbonate and bicarbonate, they will carried out together in the same solution. You know, you measure you titrate for carbonate, then you titrate for chloride. You don't need to take another sample normally. After titration for carbonate, or bicarbonate, sorry, after titration for bicarbonate, you simultaneously go to determine the chloride in the same in the same solution. So from practical point of view, it is normally done like this, and this will save time and also save some soil extract or filtrate from soil saturation extract. Any comment? Any comment? Valerie.
Yes, I'm here. Thank you. No comment.
Maria.
No, thank you. Everything is clear. Thank you.
Welcome. So we can move to the soluble sulfate. Hopefully, Maria, with soluble sulfate, you do something as we agreed that you will check. But in general, I will try to explain the basic way or the principle for determine soluble sulfate in soil. As the other previous cations and anions, soluble sulfate is obtained in the saturation extract, and it can be determined by gravimetric method as a barium sulfate or calcium sulfate. Normally, the best way to make a precipitation from solution containing from sulfate, soluble sulfate, is converted into precipitate of barium sulfate or calcium sulfate. Then it can be measured based on what's the atomic weight of barium sulfate. They will be apart from it to be a sulfate, and other part will be a barium or calcium. So you make a ratio to identify or to determine the sulfate from the barium sulfate. The importance of sulfate is very important micronutrient. Sulfur and nitrogen, both of them, they are essential nutrient for building protein and blocks of the blood. And sulfur deficiency actually will severely reduce the efficient use of nitrogen, and this of course will limiting the senses of protein. So with sulfur, all issues related with protein senses, and this is a very important physiological process in the plant. During the industrial period, and still it is industrial, the sulfur oxide come from the burning of fossil fuel, add a substantial amount of sulfur to the soil. But recently there is many regulation that reduce, or many regulations that govern the production of sulfur dioxide from industry. So there is, as a result, the concentration of sulfur dioxide in atmosphere is decreased. Of course, this is a very good practice, but on other hand, it reduces the sulfur dioxide concentration in the atmosphere, and for this reason, there is a need for sulfur fertilization to compensate the reduction from this regulation. Sulfur taken by plant in form of sulfate, and it is readily available for the blood, and like nitrate, since it is soluble in water, so it is subjected to high leaching, so it's liable to loss through leaching. Spring application of sulfate fertilizer is recommended, and this the plant can take it during the period of active growth with nitrate. Fertilizer application, especially in our region, I think is very important because it can help also to reduce the pH. And as you know that in arid region in general, the pH is high, is more than, normally it is more than 8.5, and this will hinder the availability of micronutrient, especially like phosphorus, and micronutrient like iron and zinc. Therefore, it is always recommended in arid regions to add sulfur to improve the nutrient availability for the plant. And also, if we try to revert again the issue of sodicity, the major reclamation procedure for sodic soil with high sodium is through application of silver or gypsum, and both of them, they are provider of silver for the soil and for the plant. So even the physical condition of the soil can be improved by adding fertilizers with silver or with sulfate. this when we come to the recommendation, I think we can check this issue again. Normally, when you add fertilizer, you have to thinking about how fast this fertilizer will increase or decrease the pH. So if you have a choice for urea, for example, and for ammonium sulfate, if you have a pH very high, so in such case, it is better to use ammonium sulfate rather than urea, because ammonium sulfate will provide some sulfate which will decrease the pH. So the issues of fertilization and recommendation based on soil results is a very comprehensive thinking way, and you have to link all things together, not only concerning of one factor. For instance, for example, when you're thinking of adding sulfate, you have to think how this will affect other factors like pH and availability, of course, of other macronutrients. As I said, the principle behind this methodology, it is a source of production of precipitate from barium sulfate or calcium sulfate, and this done under acidic condition. So you just converted sulfate into barium sulfate or calcium sulfate, and both of them, they can be by gravimetric method to be collected as a precipitate and then measured. I get a note from Maria that you use in the water, and it is actually, as we discussed in our talk, that the same principle is correct. Both of them, they are from the water. You are not for water you deal with water, and for soil at the end you deal with the water from soil saturation. So at the end, both of them, they are water. So the same procedure is followed, but I get a note from Maria that you use spectrometric method, and you just rather than weighting of precipitate, you get the solution into spectrometry and using standard solution at the end. And this is correct also, and but here you have to add some conditioner that to keep the precipitate in a solvent way, so that it will not going to precipitate in the bottom of the crucible or flask. It will be kept in the salt within the solution, so it keep homogeneity. So you have to add some conditioner. I discussed with Maria that we can follow this methodology since it is already adopted on practice in laboratories of Lebanon. The sample preparation, like others, is always it is air dry soil sieved through 2 millimeter mesh, and this is quite suitable for this procedure. Sorry for this, but because the sample preparation, there is no difference, I keep the reagent needed for this procedure: an indicator, methyl orange, 0.01% in water, hydrochloric acid, approximately 1 normality to provide acidic condition, and barium chloride, approximately 1N. And this can be prepared by dissolving 122 grams of barium chloride dehydrate in water and dilute to 1 liter. Then ethanol 50% by volume. In this methodology, as I said, the idea is that you will go to precipitate barium sulfate. In other cases, and you can use calcium chloride, and in both cases, you will precipitate barium sulfate or calcium sulfate. Within gravimetric method, you will going to filtrate till you reach the point that you get the precipitate at your filter paper. The procedure pipette and aliquot containing 0.05 to 0.5 milligram of sulfate into a clean 20 ml conical centrifuge tube of known weight. Then you will dilute or evaporate to about 5 ml. Add 2 drops of reagent methyl orange, 0.01, then hydrochloric acid dropwise until pink, and then 1 ml of hydrochloric acid in excess. Heat to boiling in water bath. While twirling the tube, add 1 ml of barium chloride dropwise. Return to the hot water bath for 20 minutes and then cool at least an hour in air. And this process will produce a barium. Then you have to centrifuge at 1000 for 5 minutes. And then you process of separation of precipitate from the solution. Carefully decant and let drain by inversion on filter paper for 10 minutes. Wipe the mouth of the tube with a clean towel or lengthless filter paper. Stir the precipitate and rinse the side of the tube with the stream of 5 ml of reagent ethanol, 50% blown from a pipette. If necessary, loosen precipitate from bottom of the tube by means of wire bent in appropriate shape. Centrifuge for 5 minutes and decant, but do not drain. Repeat this washing and decanting operation once. Wipe the outside of tube carefully with the combs and do not subsequently touch with fingers. Dry overnight in an oven at 105 degrees Celsius. Cool in desiccator and finally wet the precipitate. The calculation: sulfate in milligram per liter equal the weight of barium sulfate in milligram multiplied by 8.568 over ml in aliquot. There must be some note that the precipitation or concentration of unknown also can be precipitate. So you have to take care of foreign material which may be weighed as barium sulfate. And this is the reference for that. Basically a red shirt. And for important of soil, sulfur in soil, the second reference can be further reading. This is the 4-sulfate. This procedure is, I think it is very long. And even it have a lot of sources of errors because you are dealing with filtering, decanting. So, and it need to keep the weight away from the influence of hygroscopic water from. So it need a lot of accuracy and even precision to ensure that there will be no errors concerning the weight of precipitated barium sulfate from the sample. And for this reason, really I appreciate or I encourage the process of using spectroscopy rather than process of weighting. And but in general, this procedure is well known, and also it is typical to similar to the methodology used for gypsum determination. So I try to give the theory and the procedure for that because it is very similar also to determination of gypsum by gravimetric method. So it will be helpful if there is no spectrometer to be used, but if there is a spectrometer, I think the other one is suitable by using a spectroscopic methodology that used in your laboratory in Lebanon, especially for water analysis, determination of sulfate in water. Any comment? Any? Any comment? The floor is yours.
I think everything is clear for the people.
So we can move to Maria if she did something. I will stop sharing to give you the Maria.
Okay, good morning.
Mm,
And I'll try the camera can take. Is it clear?
it is clear. It is very clear. Yes.
Okay. So I prepared, we will do the sulfate from soil suspension. I have prepared for water, as done for water, we have to do a 6-point standard from a solution of 150 ppm. We did 6 points. Okay. I have prepared as in this table. And I took 1 milliliter for the first one, 3, 5, 7, 10, and 9, and then 10. In if هذا fuel 50 milliliter و dilution with water. So the final
ضرب الوتر قالنا امبارح ذيك مره والصفات بالوتر رجعنا.
the final volume is 50 milliliter. So we did it. I prepared, and we took also 1 blank, also 50 milliliter of distilled water. From the suspension, يعني متوقع انه يمكن يكون في عندنا كثير سلفيت. I did the dilution يعني 1/5 also 5 times يعني 10 milliliter of the suspension in 50 milliliter of water. I will start now by adding the HCl 10 milliliter, 1 for every airline. And the barium chloride solution used, we add to it polyvinyl pyrrolidone. This agent inhibits the precipitation of barium sulfate. So it will be as suspension. We add 5 milliliter. So as we see we have barium sulfate suspended in the solution. It seems that the soil, I did too much concentration. But because the solution is still clear. What do you think, Dr. Dafalla? How many? كيف بدي أعمل dilution? دكتور ضف الله. Hello.
Hello, I'm here.
كيف بقدر اعمل الدايلوشن؟ انا عملت السسبنشن
1.5.
هلا جات كمان عملت دايلوشن ثاني 1.5. يمكن يكون ما بعمل دايلوشن بياخذ دغري 50 ملل.
يعني زي ما تفضلتي انه انت توقعتي في الاول انه يكون في سلفيت كتير، عشان كده عملتي ديليوشن، صح؟
صح.
لكن هنا ما في ديفلوبمنت اوف كلر كان
يعني ايه السولوشن از ستيل كلير. اذا بنقارنها مع ما بعرف اذا اخذتها الكاميرا مزبوط، انه في عندنا نحن مش هو الكولور هو لونه ابيض، يعني ما انه كولور بس انه منه كلير، بصير تروبلي يعني
ما في. طيب ما بتضيفوا اي كونديشنر؟ ما في اي كونديشنر؟ احتمال يكون التركيز بتاع السلفات يكون بسيط، عشان كده الديليوشن بيكون
ايه صح. انا راح اخذها از يعني.
كان افضل، احسن تكون هي نفسها
without dilution.
ايوه without dilution.
المشكله انه ما عملت فلتريشن مضبوط، عم تاخذ وقت. انا حضرتها الصبح.
Sulfate by using gravimetric method. Gravimetry is nothing but you have to measure the weight of the sample.
هني ما طلعوا الفلتريت 50 ملل، طلعوا 42 بس حاخذهم. ما في لزوم ننطر. We don't have to wait time, so we can go on to do on the spectrophotometer directly. But كمان it is still clear, so I think there is no sulfate.
normally in the Lebanese soils, what's the sulfate percent normally?
I don't have idea. I don't know if Dr. Talal can give us the result.
How much, Falari?
The wavelength is 650. The reading of the first standard is 0.012. The second one 0.013. 48, 0.048. The third one, 0.087. For 0.137. The fifth, the 51166, and the last one, the concentration of the greater standard is 30 ppm. Is 191. And now for the sample. Zero point 011, and as the concentration is as the first standard. So we can say that there is no sulfate or in the soil. يعني هلا اكيد يبقى نعمل الكاليبريشن كيرف وما بعرف اذا في معنا وقت حتى نعملها هلا على الكمبيوتر ونطلع الكونسنتريشن.
May it also need sometimes to develop the sulfate in the suspension, not immediately.
Not immediately.
Mm.
It's still clear. Because for water, we did the same.
If you have potassium dichromate, add a drop if you have.
Potassium dichromate.
Yes.
Used for
or potassium chromate.
Chloride.
Potassium chromate. Potassium chromate.
As for chloride.
Yes.
I will add drops of potassium chromate. The color changed to yellow. I don't know if it's okay. So we have to add this to all to the blank and for the standard also. Okay. What do you think, Doctor?
The water is from a well?
No, it's a soil suspension.
Huh?
It's a soil suspension.
Okay, the soil is not rich here in sulfate in Lebanon.
Oh, that's what.
It's very poor in sulfate. It's not saline. unless you.
Our written work we didn't do
I would advise take the شو اسمه
tap water.
tap water. Yes.
But the chloride is high, yeah? Normally there's some.
The chloride is not high in the soil. Of the normal content is less than 20-30 centimole per kilogram. ppm, I mean, in the soil. For this reason, when we analyze the movement of soluble pollutants from the soil to the groundwater with the soil solution migration, we used potassium chloride in 2000 ppm applied after dissolving in water, applied to the soil surface and followed the peak of the chloride. The peak of the chloride, because the background value of chloride in the Lebanese soils is low. Whereas you can find it a little bit higher in the groundwater.
I preferred one from the tap water.
Maybe this is the reason why you are not measuring sulfate in the soil.
Yes, if she takes tap water, she will get results. She will get something similar to the Arak color. No? Did you find
yes.
a white sediment or what?
It should be something white sediments, precipitation. Yes.
Yes.
Yeah, barium sulfate.
But we use the polyvinyl pyrrolidone to inhibit the precipitation of barium sulfate. يعني حتى نقدر نعملها على سبكتروفوتوميتر لتضل in suspension. بنزيد هيدا الايجنت مع مع الباريوم كلورايد.
هو الفكره بتاعت السبكتروسكوبي لازم يحصل ديفلوبمنتال كلر، لو ما حصل ديفلوبمنتال كلر ما بيكون في تباين اكيد طبعا. لكن انا افتكر انها هي كطريقه سهله، يعني ظاهر انها اسهل من الطريقه ظاهر انها من
اسهل، ما بتاخذ وقت
يعني اسهل من الطريقه بتاعت انك تكون باريوم سلفات، سلفات الباريوم او سلفات الكالسيوم، وبعد ذاك تعمل عمليه بتاعت غسل عشان تفصل بين البريسبيتات والسوليوشن. بعد ذاك توزن البريسبيتات المتكون، ولازم يكون بعد ما تدخله في فرن، ويكون عندك ديسيكيترز برضه مجفف، ودي دائما بتعمل مشاكل في المزله بتاعت الوزن، يعني دائما بيحصل خلل في الوزن، لانه الهيجروسكوبيك ووتر او المياه الملتصقه بالجزيئات دائما صعب انها تكون الزول يقدر يتحكم فيها، داير بريسيجن عالي جدا. فالطريقه حقيقه بتاعت السبكترو جربتها ماريا، يعني طريقه ممتازه جدا ممكن الناس يشتغلوا بيها، لكن زي ما تفضل دكتور طلال انه الاراضي اللبنانيه اصلا ما فوقها كبريت. طيب الجبس برضه بتجيبوه من برا ولا كيف؟ يعني لو احتجتوا لجبس
It is imported, yes.
الجبس برضه ما عندكم مصادر بتاع الجبس لا في التربه؟
No. We don't have gypsum soil. No. We import it, yes. But we have here cement factories in Lebanon. who use local material, local soil material.
Mhm. ماريا يعني شاكرين
Yes.
شاكرين شاكرين. انا هعمل معاكم شيرنج برضو لفيديو كان للطريقه بتاعت السبكترو.
Determination of sulfate. Principle. Sulfate ions are precipitated in the form of barium sulfate by adding barium chloride in slight excess of water acidified with HCl. The light absorbance of barium sulfate suspension is measured by photometer at 420 nanometer, and sulfate concentration is determined by comparing the reading with a standard curve. This method is called Turbometric Method. For this experiment, we need sample, barium chloride, conditioning reagent, the apparatus conical flask, measuring jar, pipette, and a glass rod. Let us start the experiment. Pipette out 100 ml sample into a clean conical flask.
الشاشه شايفينها معي مشكله؟ You see the video, yeah?
Yes, she doesn't respect the safe and safety for the laboratory.
Measurement, yes, yes.
No gloves, no pipette, no pro pipettes.
Conditioning reagent
Yes.
and mix in the stirring apparatus. Add a spoonful of barium chloride crystal and begin to measure time immediately. Stir at a constant speed by using a glass rod. After stirring, pour solution into an absorption cell of photometer and measure absorption at a 30 seconds interval for 4 minutes. Take the reading corresponding to maximum turbidity occurring within 4 minutes. Correct for sample color and turbidity by running blanks to which barium chloride is not added. We get the absorbance of sample is 0.23. Measure the sulfate content from the calibration curve. From this, we get the sulfate content is 22 mg per liter.
So the other video shows that the spectrometric method is very nice, I think, and it's very straightforward, not like the traditional tedious one that take long time and need a lot of work to keep a high precision level. What do you think? You hear me?
Yes, now we heard you.
Now?
Yes. Did you
Oh.
say when you stopped the video, the YouTube video?
Yes,
You
yes.
said something else after it? If yes, we didn't hear it.
Actually, I just highlight again that the spectrometry method, somehow it is straightforward and easy, and not like traditional convenient one that require precipitation and separation between precipitate and solution. So actually, because your soil is not has that much sulfate, maybe it is not a big problem
It's
for
poor
you,
in
but
sulfate.
yeah, but in general with arid soils, especially in Sudan and others, I think North and North Africa and other Near East countries, to determine sulfate is a big problem because it takes long time and it need a lot of precision. But this spectrometry is very nice, and I will try also in Sudan to propose this one, because really here we want to make measurement for gypsum and for sulfate, but because this the well-known methodology, it needs, as I said, gravimetric method is tedious, take long time. Even from the procedure, do this and do this. So even when you lose the opportunity to have an accurate measurement of the weight and the interference from the hygroscopic water and all this. So from my experience and also from the other video, I can say that the spectrometric method somehow it is straightforward and very easy. This is what I mentioned during. What do you think?
Yes, doctor, it seems very easy protocol to be adopted.
Yes, yes, yes. But you are lucky that there is no sulfate, so, but it is not too lucky, because this means that for recommendation of fertilization, you need to recommend addition of sulfate, yeah, for the soil.
It's not us who gives the recommendation.
Mm.
It's the agricultural engineer of the farmer or of the Ministry of Agriculture. It's not us.
Yes, yes, yes. Yeah, I noticed that from the questionnaire, but as Dr. Tilal said, when you are in the laboratory, many times you will be encouraged or you will be forced to give some recommendation as well. I think Dr. Tilal during his previous
yes, he used to give
he takes the responsibility, yeah.
Yes, that's what I understood from him. He took the responsibility.
Yes,
That's right.
But here you must be general, not too specific.
Mm-hmm.
Because it depends on the crops also and
yes,
the region.
Yes, it means when you find low content of potassium in the soil, for example, you must advise to pay attention to the potassium application, which must be increased, while the others must be maybe slightly decreased or maintained at the same levels.
Mm.
If the other nutrients are sufficient and a little bit high. And when I measure texture and organic matter content and gravel content in the soil sample I received, I advise to pay attention to the irrigation schedule. It means if the soil is clay, I used to advise, okay, you can make a larger interval between two irrigation. While if the soil is sandy, I warned from water stress and to shorten the period between two irrigation. I did not give direct recommendation on how much to apply. This is not my job. It is beyond the analysis, of a soil sample. Of course, I asked him what crops do they grow, and if they grow, for example, crops which require high amount of potassium, like potato, for example, tomato, okay, I can advise to pay attention to this. This is what I meant by giving recommendation, not too specific, in order not to fall into a gap of answering if he misinterpreted my advice and mismanaged application, then he will complain that I was wrongly advised, etc. So thanks God, I worked there 3 years. I didn't receive any complaint from my. Alhamdulillah. Indeed, alhamdulillah, because the advice was, you know, a little bit general concerning the concept itself, not the details management. The detailed management, it must be based on specific, you know, crop, soil, climatic conditions, you know, availability of water, type of crop, nutrient demand, water demand of the crop. A lot of factors must be considered.
Yes, you are right. Absolutely true. But I think that it is a very special case. Normally, the soil laboratories, in a way or another, they are enforced to give some interpretation of result, and maybe this is the reason behind you are requesting to get some basic principle for interpretation of soil result. And if you are enforced so that you can have the necessary knowledge regarding the interpretation of soil results and give some recommendation. And therefore, during this training session, we provided a room for report writing, interpretation of soil results, and this, I think, at the end days or the last periods, we will have to get closes. And of course, this will be helpful for the laboratory workers, that at least when you are making analysis, you understand the importance of this measurement you carried. So, and it will give you also, it give an opportunity to interpret and give at least general recommendation. And this will be very helpful for sustainable management of soil resources.
I used to receive, you know, the soil analysis results from Larry, which contain on a template form the content of different nutrient, and at the bottom of the page there was interpretation of results. That, for example, the content of nitrogen is low in the soil. The content of potassium is sufficient, for example. The content of phosphorus is poor, etc., etc. But they cannot go into recommending how much fertilizer to apply, for example. This is the work of extension service, I think.
Yes. Yes. Maria في تل العمارة, what's the situation regarding the result interpretation? And Abir also from Sur, I see. Yeah.
بالوقت الحالي ما عم نعمل ريكومنديشن، عم نعطي صفحة إرشادات قديش مفروض يكونوا كل باراميترز، ونحن ما بنكتب كومنت مثل ما كنا نكتب قبل، مثل ما عم بيقول دكتور طلال إنه فقيرة بهيدا، غنية بهيدا العنصر أو لا. فهلا بالوقت الحالي ما عم نعمل هيك، فعم نعطي صفحة الإرشادات، وبما إنه كل مزارع هو عنده مهندس أو في حدا عم بيتابعه، هن عم بيعطونا الإرشادات، لأنه هذه الشغلة كتير عم بيطبقوها يمكن غلط إذا عطيناهم شيء، إذا صار في شيء مشكلة عم بيحطوا الحق علينا، فعم تعمل كتير مشاكل. فكرمال هيك نحن ما عشفتنا بهذا الموضوع.
It is similar also in Sur and other laboratories, yeah?
Yes, it's similar, doctor. It's we all the same.
Yeah.
Yes, doctor, it's similar.
Yes, it is also in Lebanon. That's similar.
Yes. As I think this is as you said, it is a general practice in Larry in general that you are not authorized to provide recommendation because there is someone in Ministry of Agriculture who is extension service who is responsible or is has a right to give a comprehensive recommendation.
Yes اسمه المكتب الإرشاد الزراعي بوزارة الزراعة هو بيهتم بهدول الأمور.
Okay. And this system is work well in general, yeah?
I didn't understand it what?
يعني النظام ده ماشي كويس يعني في النهاية بدي في النهاية بدي ريكومنديشن واضحة للمزارع وممكن يستفيد منها في عملية أنا ليه بسأل السؤال ده لأنه هو في النهاية المعامل هي مفترض يكون الاوتبوت بتاع النهائي إنه إدارة جيدة للأراضي وزيادة الإنتاج وكده يعني مش الريزلت الزول بيشيلها بيحتفظ بيها في مكتبه مثلا هو في النهاية داير يحولها لخطة بتاعت عمل لإدارة مزرعته لزيادة إنتاجيته لتحسين إدارة المزرعة نفسها فدي ده السيستم أو الفائدة من عملية التحليل نفسها يعني فإذا السيستم ده شغال أوكي خلاص ما في مشكلة إذا في لحظة معينة بيحصل بريكج أو ذيس تشين يعني بالتالي بيكون الاستفادة من التحاليل بتاعت التربة قليلة يعني unless there is a very good implementation of this system to provide a very concrete recommendation for farmers then the analysis the soil analysis will not help much in the process of sustainable soil management of Lebanon. This is my actually my discussion point or intro point. You get me?
Yes, we get you.
You know, the Larry, the situation here, they work with farmers usually, but not in concerning the interpretation of and soil management, direct soil management aspects. They have several projects regarding the land use management, irrigation management, cropping system, you know, drought details, aspects. But concerning the interpretation of soil analysis, I understand that some people can complain, okay, you gave me this recommendation and it did not work, for example, okay? The private sector in Lebanon here is not, you know, is not objective a little bit. Their own mistake can be allocated to others' mistake, you know. So why to have this headache? Yes, indeed. This is might cause
headache. Yes, I know. Yeah.
Yeah, because people now can go to the social media and write two lines which can undermine all your work. Larry has been doing a lot for the country for this 50 years or 60 years of existence. So they are doing now very good. It's like a health laboratory. They provide the analysis and they give the standard for every factor and every element. You go to the doctor, and the doctor gives you the medicament. And they are doing the same now. They are providing the soil analysis with the thresholds for every element. You must go to an agronome, agricultural engineer who can help you. But people don't want to pay, they want to get all profit without sacrificing a small amount of investment.
Yeah. Actually, yeah, I understand that. Of course, this will be a headache or will be another job. And of course, I understand your point. But actually, I try to understand the situation, and also in comparison with other Near East countries. For instance, here in Sudan, for example, normally the farmer get a comprehensive report with recommendation with the data, so that I can ensure here that the contribution of soil laboratories in sustainable management of soil and land in general is very appropriate. And even this is a situation in Yemen, in Oman. So, but in case, because here you have some complication related with issues of, so the result will be given to the farmers, with hope that this farmer will go to the another agricultural engineering, so he can get the final benefit of the soil results. Here the chain is somehow long. Maybe this discussion, our daily discussion, maybe if the people saying that it is possible to improve the way of using the data from soil analysis for sustainable soil management, maybe there is a need for bringing or establishing a very good link between Ministry of Agriculture and soil laboratories. And this, of course, will need some changes in policies and so on. But in general, I think it is okay that, as you said, you can give the result with the threshold and with the level of characterization of the soil parameters, and then the agricultural engineering can take decision upon this based on this result. But in general, it is general thinking or general discussion. But it depends, of course, on the national circumstance or natural condition.
كيف الحال؟
السلام.
كيف؟
الحمد لله.
كيف اخبارك؟
الحمد لله.
الحمد لله.
The floor is yours.
Hello.
If there is no other comment, discussion, do we need to take break or to go to the final one, that organic carbon for today? What do you think?
We can have a break.
For?
No, because I have to go sign some papers.
No, I mean how many minutes?
10 minutes, maximum 15. Just to go to the other buildings to sign the papers, my contract of work, then I come back to the lab.
So we 15 minutes, yeah?
Maximum 15 minutes I need, yes.
Okay. Then it is 15 minutes and come back to them.
Okay, thank you.
Welcome. Hello, I'm back.
Hello.
So we can
Hello,
proceed.
Doctor.
Hello, Dr. Talal.
أنا يوسف
Hi.
أهلا يوسف.
هلا.
دكتور محمد،
أهلا.
بدي اسالك سؤال من المره الماضيه
تفضلي.
عن البيكربونات. هلا
Yeah.
نحن وقتها لما كنا عم نجربه زدنا الفينول الفتاليين ما عطى بينك كلر. هلا برجع اقرا البروسيجر، هن كاتبين if pink color develop، يعني منه بالضروره يكون في pink color او لا.
هو بالضبط الفكره ايه، انه اذا عاده الكربونات بتتحول بسرعه لبايكربونات، يعني فلو كانت موجوده حيحصل الكلر يكون يدي بينك، لكن على اللي بيحدث انها سريعه التحول من كربونات الى بايكربونات، يعني نادر تلقي في العينه يكون فاضل كربونات متبقي.
والبيكربونات ما بيعطي pink color.
ما يعني almost بيكون all the carbonate is converted into bicarbonate. Therefore, you will not find any carbonate.
Okay.
Normally, with the soil sample, it should be very fresh and very quickly to determine the carbonate. Otherwise, it will convert it to bicarbonate. You get my point?
I get your point, but in this case,
They will be.
We must do any step more to
just
ensure that we have the carbonate. It doesn't transform to bicarbonate.
We just in this case we said that the carbonate is nil, and then you go to the other step to determine bicarbonate.
Okay, we do the next step.
يعني لو ما تم اجراء المعايره بالسرعه، يعني المستخلص السسبنشن immediately بس بعد الحصول عليه يجب اجراء المعايره لتحديد الكربون. لو قعد يستقر شوي على طول بيتحول لباي كربونات، فانت هنا في الحاله بيكون الكربونات زيرو because it will go to convert it into bicarbonate. بيكون البايكربونات دائما كتير.
اوكي. ثانك يو.
يا دكتور محمد.
تفضل.
نحن محطة صور على أساس نعمل تست كلورين، بس كان في مشكلة بالكهرباء ما حضرنا الفلتريت، صور فلتريت، بس هاي كانت المشكلة.
ما في مشكلة إن شاء الله. هو الكلور يمكن كان توضيح من يعني التوضيح بالصور كان جيد جدا، وكان خالص.
واضح جدا.
كان واضح جدا الحمد لله.
يعني
لكن هي انا شاكر جدا، يعني انا شاعر انه الناس قدروا يخلقوا البراكتيكال باسلوب مناسب، يعني تكيب الناس في او تخلي الناس يكونوا في الجو بتاع العملي، فدي الجزئيه المهمه. يعني زي الطريقه بتاعت انك انت بتدي البروسيجر، بعد ذاك الناس بيقوموا يطبقها فرد منهم، بالتالي بتديهم فرصه بتاعت انه يتعرفوا على الطريقه بشكل
أنا رجعت. I'm back. سوري إذا أخرتكم.
لا ما في تأخير، بس إن شاء الله الورق اتمضى، تم توقيعه.
إيه نعم. مضيت على العقود.
طيب الجزئية الأخيرة إحنا حنكون Organic Carbon Black Method. This is a standard operation procedure for soil organic carbon using Walkley and Black method, and this one is published from FAO and Agriculture GSP and it's supposed to be, they will encourage people to use it because it get the version history. It shows a description of the modification. It is finalization of the draft version, type of modification, compilation of all inputs received by regional soil laboratory network. Approved date, CERT NASOLAN meeting, validation date 27 October 2019. So this SOP number 2 for NASOLAN, and version number 1, number of pages 25 pages. Actually, nowadays, soil carbon is get a lot of tension and a lot of concern because it has a very important effect on the soil in specific and climate in general. So the soil carbon actually significantly affect almost all soil properties, that the physical and chemical and microbial properties of the soil affected by soil carbon. Carbon, there are two types, basically, organic one and inorganic one. So the carbon as the soil organic matter changes the physical, chemical, and biological properties of soil. There always is a synonym word by soil organic matter and humus. And also the humus is more commonly used when referring to the well decomposed organic matter. When the organic matter is fully decomposed, it converted into humus. But soil organic matter it consists of solid and soluble part, not like humus. But in general, people use sometimes humus, sometimes soil organic matter. But from my physical point of view, I think soil organic matter is comprehensive, and including some indication of physical condition of the soil organic. When we say soil organic, it could be still not decomposed, so still it has some structure. While when we talk about humus, or normally we talk about well decomposed. And normally here the structure of it is tend to be more soluble rather than soil organic, in which we expected to find some solid part. As I mentioned, the soil carbon become a very important issue regarding relation to climate change, because the soil carbon and sometimes soil carbon sequestration, which means that the storage of carbon in the soil is considered to be the third largest carbon ball in the Earth system. And this play a very important role in managing and govern global carbon cycle. And you know that climate change, one of the main sources of it, is increase of concentration of carbon dioxide in atmosphere. So if you keep some carbon in the soil, you can have an influence on the climate, and this will reduce the high level of calcium, high level of carbon dioxide in the atmosphere. In the soil, most of the carbon is held as organic carbon, soil organic carbons. In arid and semi-arid region, the most common form is inorganic carbon, primarily carbonate. And this is very clear in arid regions, that you will find a high level of calcium carbonate or magnesium carbonate. And both of them, they have a carbon part, which is at the end is carbon. While in soils, organic carbon, soil organic carbon considers a major source of carbon. And you know that organic, when we talk about always organic, is that carbon come from living organism, whatever they are, crop residue, the remaining of diet, macro and microorganism, all these constitute or forming soil organic carbon that coming from the living organism. While the inorganic, it comes from weathering of rocks, minerals, precipitation of certain minerals under certain condition. As you, from the sulfate, that for example, if there is carbonate and sulfate, they will together combine to form a precipitate, or in such case a gypsum, for example. So for this importance of carbon, so the quantifying of soil organic carbon and soil inorganic carbon is essential to understanding the carbon cycle at regional and global scale. Really nowadays there is a high concern of soil carbon, whatever it is, organic or inorganic, and this is actually relation to process. مشكلة التغير المناخي ألغت بظلالة شديد، وزادت من الاهتمام العالمي بالكربون الموجود في التربة، سواء كان هذا الكربون من مصدر عضوي أو من مصدر غير عضوي، نتيجة لأنه هو ده بيساعد في إنك تقلل التراكيز الموجودة بتاعت كربونات ثاني أكسيد الكربون الموجود في الغلاف الجوي، نتيجة للعملية بتاعت industrialization. The level and concentration of calcium of carbon dioxide is very increased during the last centuries, and this of course lead to problem or phenomena of climate change. Therefore, there is a high concern of studying and quantifying and even increasing the concentration of soil carbon, whatever it is from organic or inorganic origin, so that to sequestrate and store this carbon dioxide in the soil and not allow it to come or evolve to atmosphere as a process for mitigation or reduction of level of carbon dioxide in the atmosphere. As I mentioned in the first slide, that the soil organic carbon is very important for all the soil properties, especially if we come here to the chemical properties of the soil. Soil organic carbon increase the exchangeable capacity, cation exchange capacity of the soil, because it has some negative charge, so that it can exchange, or it can capture and fix some cations, and this of course will help for increasing the exchange capacity of the soil. These cation exchange sites are important for retention of nutrients such as calcium, magnesium, and potassium. And also organic carbon, soil organic carbon, providing a binding site for many anthropogenic organochemicals, and this will minimize leaching of hazardous chemicals through the soil profile or making them less bioavailable, which reduces toxicity. And this is, of course, all this together, it helps in two points here. It helps in improving the soil fertility. When we talk about increasing cation exchange capacity, actually this will influence the soil fertility. And when it binding hazardous material, this will improve the eco surface of the soil. Eco surface, that the soil has some surfaces for ecology and for ecosystem in general. So when binding these hazardous chemicals, this will help the soil to prevent water and soil pollution in general. And this is together, they are related to the soil fertility and related to ecosurface of the soil as a filter for chemicals, hazardous chemicals that to leach and come to the soil, and also to the water, groundwater, if the water table is very low. Of course, if there is organic carbon, this will enhance the biomass and diversity of soil biota, because most of the soil biota use the organic matter in their process of feeding. So they use this organic matter to produce from it energy that is necessary for them to continue their physiological process. The microbial community as well improves the condition of the soil organic, because they are produce some organic matter. The most pronounced one example that excretion from organism, of course, will excretion from organisms that will increase the soil organic matter. And in some cases, that the availability of some nutrient will be improved by adding soil organic matter, because at the end, the soil organic matter will change to humic acid, which this will make some changes and modification of soil pH. Therefore, in most of the arid soils, it is always recommended to add organic matter, because it will help in basically two issues. It will improve the soil chemical condition and soil physical condition. And together, this will help in maintaining a good crop growth and provision of nutrient and water as well. Is this part in the soil classification system? Always organic matter is very important. Normally, the soils classified into two big broad categories: organic soils and inorganic soils. And organic soils and inorganic soils, normally inorganic soils called mineral soil. So we have two broad categories: organic soils and inorganic soils, between bracket mineral soils. So the amount of the content of organic carbon of mineral horizon can be estimated from the Munsell color. You know that the Munsell color is a color chart to identify the color of the soil, and normally it consists of three parameters: hue, value, and chroma. If you get in touch with this Munsell, it consists of basic three parameters: hue, chroma, and value. In general, hue is a dominant color. When you said this soil is red, this is hue, and the other one is, for example, black. This is red and blue. Identify the hue. Then you will go into the level of within the color. Especially ladies know well that when I said red, there is some levels of red. Dark red, bare red, and this is another issue that related to chroma. So in general, with Munsell color, you identify the color of the soil. In general, dark color soils has high organic carbon, because you know that the organic carbon itself, it is black. So when there is a black soil, this give an indication this soil has high organic matter. And if the soil is light color, this indicates that the soil has a low organic matter. But of course, this is a rule of thumb and very general, because in some cases, although the soil is black, but it doesn't mean that it is this blackness come from the organic matter. It is one factor analysis. For example, the clay soils in general, they are black, but this does not mean that this soil is has a high organic matter in comparison with the soil in temperate area where there is peat moss formation. The soil there, maybe the light is lighter than black, but still it has a greater amount of organic matter. يعني in general اللون هو مؤشر، لكن ده مؤشر عمومي. في بعض الأحيان ممكن بعض مثلا الأراضي الطينية ممكن تكون لونها بلاك ناتج من وجود الكلي نفسه، لكن ما معناها إنها مثلا عندها مادة عضوية أكثر من تربة متكونة تحت غابة، أو التربة تحت غابة اللون بتاعها بيكون أفتح من الأراضي الطينية، لكن المادة العضوية بتكون أكثر. So in general, in the process of soil classification, the content of organic carbon is very important to identify the soils, and normally the soils are classified into two broad soils: organic soils and mineral soils. According to the Food and Agriculture Organization of the United Nations 2016, organic carbon content of more than 0.6%, then this will indicate that the prevalence of a specific soil horizon known as molic and ambric, while organic carbon content more than 1.5% is indicates the presence of phronoic horizon. There is a very important point that normally the organic carbon to organic matter is about 1 to 1.722. Normally, in most literature, the people use 1.7. this is to convert organic carbon to organic matter is done by multiplying the organic carbon by 1.72 in general. But this ratio somehow is subjected to some variation, because in the methodology, normally in the methodology, actually you are determining the organic carbon, not organic matter. But by the end, you want to know the organic matter in your soil. So you have to multiply by a certain factor to convert organic carbon into organic matter. As I said, that the soil organic matter is the primary indicator of soil quality. Normally soils with good organic matter content, its quality is good in comparison to the low one. And improvement in soil organic matter create or provide a more favorable soil environment, and this will lead to increase and improve the plant growth. In general, soil organic matter increase the ability of soil to store and holding water. Also, presence of organic matter will improve the aggregation of soil particle, and this will improve the soil structure. If you remember from our previous lectures regarding calcium, magnesium, and sodium, we talk about dispersion versus fluctuation, flocculation. That presence of high level of sodium in the soil will lead to dispersion of soil particles. But organic matter work in contrast to the sodium. It brings the soil particles together to flocculate, and this will help to keep a very good structure. As we mentioned in that lecture, that dispersion of the soil will lead to a bad physical condition and accumulation of soil particles in the pores, which will close these pores and prevent presence and availability of water and air. So normally organic matter is in most of literature considers as conditioner rather than fertilizer, because it conditions the soil physical condition into from bad one or from bad structure, bad soil condition into good one. And this, of course, will help in provision of water and air for the plant. In addition, of course, to better root growth and others. Regarding soil inorganic carbon, as I mentioned, it is normally formed as carbonate, calcium carbonate, magnesium carbonate. Normally, it is determined by measuring carbon dioxide production after adding hydrochloric acid. When you add hydrochloric acid, actually the soil inorganic carbon, basically from carbonate, will be evolved as carbon dioxide. And actually, you did it in your practice. Normally, when you want to measure the calcium carbonate by calcimeter, By calcimeter, you add HCl. So the loss in weight will give you percent of calcium carbonate. So here you are not only this loss in weight, it is not an indication only on calcium carbonate. Instead, it is also an indication of soil inorganic carbon. There are many methods to measure organic carbon. Most of them, they are very easy. But a special effort should be made by soil analysis laboratories to provide the best possible quality data. We can talk a little about these methods. You know that there is someone, basically they are divided into two types, dry combustion and wet combustion. Dry combustion, that you are put the sample in a furnace and you ignite it in 550 degrees centigrade. Then the loss in weight of the soil sample is contributed or is measured to be the value of organic matter. This is a very common method that normally known as dry combustion. And this will give you a very reasonable measurement of organic matter in the soil. As I said, it is very easy. You just combust and ignite the soil sample, predefined weight of the soil, and then you put it in furnace for 2 hours, and then the loss in weight is attributed to or assigned to the percent of organic matter in the soil. The other method, normally they known as the wet digestion, and actually black and oily method is belong to the wet digestion, in which you just combust the organic matter by using sulfuric acid. The availability and easiness of this methodology, all this will allow to monitor changes in soil organic carbon at both local and regional scales, and this will give a better idea of future scenarios, not only for soil organic carbon content, but also for atmospheric carbon dioxide evolution. And now, I think even now in NASOLAN, there is some work regarding the global soil organic carbon. And as I mentioned, this is very important, not only from agricultural point of view, but also from people working in the field of climate change studies and mitigation especially. This is standard operation procedure. It is a scope and field of applies to determine oxidizable organic carbon content in the soil. Basically, it will determine the organic carbon that oxidized by potassium dichromate. The organic carbon content is calculated from the amount of chromic ion formed. And in this method, you can use a titration or Clarimetric method. Both of them, they are applicable. The presence of chloride interference from other anions and cation is expected. From chloride will produce positive interference in the soil. Presence of chloride will increase the value, while in manganese will decrease the value. The bias resulting of process can be corrected if required. And this method is described in Nelson and Summers. So it is this determination of soil organic, it depends on Welkley and Black method, and it depends on chromic acid wet oxidation method. The oxidizable organic carbon in the soil is oxidized by potassium dichromate in concentrated sulfuric acid. The heat of reaction raises the temperature which is sufficient to induce substantial oxidation. This is the equation for this. The chromate will be reduced, and there will be evolution of calcium, evolution of carbon dioxide, and production of water. So the reduced potassium dichromate is proportional to the oxidizable organic carbon present in the sample. Then, by process of back titrating, you can identify and measure the organic carbon by estimating the measuring of the remaining unreduced dichromate by titration with ferrous sulfate or ammonium ferrous sulfate, and using an indicator diphenylamine or penanthrolene ferrous complex as indicator. يعني في العمليه بتاعت الويت دايجيشن بشكل اساسي انت بتعتمد على عمليه ما يعرف بالباك تايتريشن، عمليه المعايره العكسيه. في الاول انت بتضيف بوتاسيوم دايكروميت، بيعمل عمليه بتاعت اكسده في ظل وسط حمضي للماده العضويه. انت اساسا بتضيف البوتاسيوم دايكروميت بكميه ازيد من المحتاج له، فاللي بيتم في عمليه الاكسده بيكون متبقي منه جزء، هذا المتبقي بتيجي تعمل له شنو؟ معايره بالفرس سلفيت او الامونيوم فرس سلفيت. فهنا بسهوله بديك شنو؟ بديك المتبقي بوريك من تطرحه من الاضفته، بديك ما تم استهلاكه في عمليه اكسده الماده العضويه، اما من تضربه في 3 بديك كميه الماده العضويه الموجوده في التربه. طيب alternatively ديك الطريقه الاولى ديك gravimetric method. Alternatively the organic carbon can be calculated from the amount of chromic ion formed, and in this case a calorimetric procedure measurement absorbance at 588 nanometer can be used. An advantage of this procedure, calorimetric method, in comparison with Titrimetric method, is that accurate standardization of the potassium dichromate solution is not required. Normally, from our previous experience with sulfate, that always the spectrometry is more easy, straightforward, and to some extent also reliable. And nowadays, a tendency to use spectrometry rather than titration. Some points should be noted that recoveries of the total organic carbon by this method can be typically between 75 to 90% in surface soil and will vary with soil type and depth. But in general, Welkley and Black recognize that an average of 77% of the organic carbon was recovered by heat. and dilution procedure, and propose that correction factor of 1.3 to be used to account for unrecovered organic carbon. Therefore, when we come to the calculation, you find this number 1.3. So you have to know that 1.3 come from compensation of unrecovered organic matter. As I said in the previous slide, that there is some interference by some soil constituent, especially oxide of manganese, oxide of hadid, and chloride. And all of these will lead to positive or negative errors. Reactive manganese will result in negative error and low values, while while chloride will provide a positive one, and there will be increase of value for organic. Therefore, the addition of phosphoric acid after the samples has cooled help eliminate interference from ferric ion. And the chloride interference can be eliminated by washing the soil free of chloride before our analysis, or participating the chloride as AgCl by addition of sulfur nitrate, sulfur sulfate to the digestion acid. يعني التخلص من الانترفيرنس بيتم بإضافة حمض الفوسفوريك للحديد بحمض كبريتات الفضة للكلور. Also, it is very important that a soil with very high organic carbon content will give a low test, because the added amount of potassium dichromate cannot be sufficient to oxidize the all organic carbon due to incomplete oxidation. In such cases, it is better to use a very small weight or amount of soil, and this will be put in the table. So a smaller sample weight should be used for sample with very high carbon content. This method basically is oriented to determine soil organic carbon, not applicable to soil containing significant amount of carbonized material. If the soil has high concentration of calcium carbonate, so this method is not good, or will not give a very accurate results. Therefore, in such cases, maybe it is better to add at the beginning HCl to get off from carbonate form of organic carbon. The apparatus, there are two for titration method and for calorimetric. For titration method, you have analytical with good appreciation, 0.0001 gram, precision balance, burette, volumetric burette, and dispenser, volumetric dispenser, Erlenmeyer flask, and the specification is clear in the. You need also oven to able to reach a temperature of 105 degrees Celsius, volumetric flask, glass rod, beakers, fume hood. It's very important that this procedure or this method to be conducted in fume hood with extraction and ventilation. and purate and standard. For Clarimetric method, you need analytical balance spectrometer for measuring absorbance at 600 nanometer wavelengths, centrifuge tubes, dispensing or volumetric pipettes, graduated pipette, calibrated dispenser, glass rod, volumetric flask, and beakers. Materials for titration method: deionized water, which should be with EC 1.5 multiplied by 10 minus 3. This is Siemens per meter. Potassium dichromate standard, 0.167 morality, 1N. And this can be done by dissolving of 49.04 gram of traceable or equivalent analytical grade of potassium dichromate, previously dried at 105 degrees Celsius for 2 hours and cooled in desiccator to room temperature. In deionize or distill water and dilute the solution to volume of 1 liter. Sulfuric acid, concentrated, not less than 96%. And this is for titration and colorimetric method. If chloride is present in soil, you have to add silver sulfate to the acid at the rate of 15 gram per liter. Also, phosphoric acid, phosphoric acid 85% if diphenylamine indicator is used. The phosphoric acid is added to form a complex with interfering ion and providing a sharper color change of the indicator. There is a possibility to use one indicator from these two. There are 2 indicators can be used, but only one should be used of phenanotoluene ferrous complex, and this can be produced by dissolving 0.025 molarity of phenanotoluene monohydride, analytical grade, and 0.695 gram of ferrous sulfate heptahydrate, analytical grade, in deionized water. Then you can dilute the solution to a volume of 100 ml. The phenanotoluene ferrous complex also available under name of ferroin, this commercial name from the G. Friedrich Smith Chemical Corporation, Columbus, Ohio. The other one indicator, barium diphenylamine sulfonate indicator, and it's 1.6% aqueous solution. For titration, you have to titrant. You just use one from these two, not both of them, only one, ferrous sulfate and ferrous ammonium sulfate. So it is must be noticed that in the both solution, the ferrous ion oxidizes slowly on exposure to air, so it must be standardized against the dichromate daily. And you have to prepare a new solution every 30 days. For Clarimetric method, you need deionized water with the same specification of the previous. You need potassium dichromate 10%. For sake of time, I'm not going to read the procedure for preparation. And also, you need a sucrose standard 4 milligram. 4 milligram per mil. In this procedure, health and safety, the procedure is involved with use of hazardous chemical. Therefore, you have to refer to laboratory safety guidelines or material safety data sheet before proceeding. Personal safety, as Falari comment on the video for sulfate, that the instructor in this video don't adopt any personal safety measurement. She don't wear safety glasses or gloves or lab coat. So all this must be, when you are carrying this process, you have to have this personal protective equipment. The chemical hazard related with the agent uses this procedure. Potassium dichromate is an organic compound and emit toxic chromium fumes upon heating. And potassium chromate is highly corrosive and is a strong oxidizing agent. And also this substance is known to be human carcinogen and is associated with increased risk of developing lung cancer. Sulfuric acid, it is known and it must be kept away from naked flames and heat. Therefore, it is very important to measure the concentration in air regularly, and that you carry out the operation in fume hood with exhausted and ventilation, and not discharge the waste into the drain, and never dilute by pouring water into the acid. And this is mentioned many times, that you have to pour in acid to water, not reverse. And regarding hygiene, there is a need for washing hands and clean other exposed areas with mild soap and water after using all chemical reagents. All titration and handling of chemical to be undertaken in a fume hood. For sample preparation, air dry soil samples that pass a sieve of 2 millimeters or less. For a procedure for titration method, take about 1 gram of air dry soil, depending on the expected concentration of organic matter or percent of organic matter. But adjusted if necessary, see guidelines recommended from table 1. We can go to the table 1. Here, the weight is varied from 0.1 gram into 0.5 gram, depending on expected percent of organic carbon in the soil. Whenever the organic carbon in the soil is increased, you have to decrease the weight of air dry soil. Then you have to add 10 ml of potassium dichromate and swirl the flask gently to disperse the soil in solution. Then with care, rapidly add 20 ml of concentrated sulfuric acid, directing the stream into the suspension. Immediately swirl the flask gently until soil and reagent are mixed, then more vigorously for a total of 1 minute. To minimize heat loss, allow the flask to stand on an isolated sheet for 30 minutes in a fume hood. Then after, add 200 ml of water to the flask. There will be a remark: filter the suspension using an acid-resistant filter paper. Example, Wattman number 540. If experience shows that the endpoint of the titration cannot otherwise be clearly discarded. Add 10 ml of phosphoric acid if barium diphenylamine sulfonate indicator is used. Add 3 to 4 drops of opinanthrene indicator or barium diphenyl sulfonate indicator and titrate the solution with ferrous sulfate or ferrous ammonium sulfate. As the endpoint is approached, ferroin titrane, when using the phenolphthalein indicator, the solution takes a greenish cast and then change to dark green. At this point, add the ferrous sulfate heptahydrate drop by drop until the color change sharply from blue to red. Maroon color is a reflected light against a white background. Diphenyl titration, when using the diphenyl indicator near the endpoint, the color change to deep violet, blue. Slow down the titration by adding the ammonium ferrous sulfate dropwise. At the endpoint, the color change sharply to brilliant green. Of course, determine 1 to 3 plank in same manner, but without soil to standardize the potassium dichromate. Compute for % of organic carbon and report as oven dry base with 2 decimal points. In case of using manual potentiometric titration, you can set an expanded scale pH meter microvoltage meter with platinum electrode and Calomel reference electrode to read electricity in microvolt. Insert the electrode and temperature compensator in the solution and steer with a magnetic stirrer. Tall foam beakers can be used as an alternative to Erlenmeyer flask, giving more room for the electrode temperature compensator and puree. Using one of the unknown, plot a titration curve by recording the values of measured electricity in microvoltage and milliliter titrant of ferrous sulfate or ferrous ammonium sulfate added from puree. The end point is then found on the point of inflection on the curve, approximately 750 microvolt. Subsequent titration are discontinued when this point is reached and the corresponding titrant consumption is then measured. If over 8 mL of the 10 mL of dichromate has been reduced, the determination must be repeated with a smaller amount of soil samples. For automatic potentiometer titration, use an O2 titrator with a platinum electrode to the microvoltage terminal and calomel reference electrode to the glass electrode terminal. Use 25 ml auto purate for the OM for ferrous sulfate or ferrous ammonium sulfate titrant. The titration is carried out by first plotting a titration curve as described above and then automatically titrated to the endpoint approximately 750 microvolt. Thus determined. Titrator setting should follow the titrator equipment handbook, and also if over 8 ml of the 10 ml of dichromate has been reduced, the determination must be repeated with a smaller amount of soil sample. The Clarimetric method, really it is also in comparison with the other one, it is very straightforward and very easy. You just prepare a set of sucrose standard as specified in table below, and volume of sucrose standard at deionized water corresponding to the mass of organic carbon. To each tube, add 2 ml of potassium dichromate solution and mix. Add in addition sulfuric acid, cool, and stand for 30 minutes. Add 18 ml of deionized water to the tube. Then you will have the standard preparation. In this preparation, mass of organic matter, sucrose in sucrose is standard, and quantity of water at the end. It all from standard and water should be 2 ml. So you add 0.25 from sucrose. You fill completed to 2 by adding 1.7 ml, and 0.5 you add 1.5 and so on till you have the mass of organic carbon in milligram 8. You add 2 ml and you add from sucrose standard, and you add 0 ml from the water. For the sample, you weigh 0.5 gram soil sample. You add 2 ml of potassium dichromate solution and mix. Then you add 5 ml of sulfuric acid, cool and standard for 30 minutes, similar like the previous one. Add 20 ml water to the tube, mix and stand overnight. For the measurement related to the Clarimetric method, you read the absorbance of the calibration standard and sample in a spectrometer set at 600 nanometer wavelengths. When the 2 or greater than 0.999, proceed with the analysis of the sample. Otherwise, if less than that, verify that the standard and reagent were correctly prepared, the instrument is functioning probably, and that the instrument setup is correct, and then you have to get corrective action. And for reporting of organic matter, it's always in given in based on dry weight and also in 2 decimals. From the calculation, for calculation from the equation, each 1 ml of 1N dichromate solution is equivalent to 3 milligram of carbon. After the reaction, the excess is titrated. Therefore, 1 ml always equivalent, 1N dichromate is equivalent to 3, producing 3 milligram of organic carbon. So for organic carbon calculation, it equal volume of the plank minus volume with the sample. From the sample, then MFE multiplied by OO3 multiplied by 100 multiplied by F multiplied by MCF. F blank, this is the volume of titrant in a blank in millimeter. F sample, volume of titrant in sample in millimeter also. And MF plus 2, this is a concentration of standardized ferrous sulfate or ferrous ammonium sulfate morality. And 0.003 is the carbon oxidized as shown below. F is the correction factor, which is equal to 1.3, and weight of the soil, and MCF moisture correction factor. And weight is the weight of the soil sample. This consideration was highlighted in the previous slides. So the correction factor 1.3 is come from the recovered percent by this method. For calorimetric method, the calculation organic carbon equal milligram concentration in the sample minus milligram in concentration of the blank multiplied by F, MCF, and 10, and divided by weight in milligram. MgC sample, it is an analyzed concentration of C in sample. MgC blank, analyzed concentration of C in blank. Weight, mass of air dry sample in milligram, and F is a correction factor, and MCF, as the previous one, is moisture correction factor. For quality assurance and quality control, we have to come to accuracy test that precipitation participation in inter-laboratory and international laboratory proficiency test is very important. Very good that now FNAR participate in this proficiency test, as Lucrezia mentioned in the beginning of this training session. Also, use of certified reference material is recommended. Precision test, and this as from our previous sessions, we get acknowledged this tested, that the precision test normally is done by doing a replicate of analysis. Then you will going to compare the relative standard deviation. Relative standard deviation is always standard deviation over a mean of the measured sample multiplied by 100. And the expected precision repeatability as a function of analyzed concentration here. And the source of this table is AOC, peer verified method program manual on policies and procedure. Of course, whenever there is increase of relative difference difference, this indicate when they are come close the value, this means that the precision is high. When it come create, this means that there is error. So then after you have to go to the corrective plan. Control chart also as well should be used to a duplicate of check sample or internal reference material for every batch of analysis. You have to plot the resulting control chart and monitor for a specified limit. If out of specified limit is observed, identify root causes, develop corrective and preventive action. Finally, this is the reference for this methodology or standard operating procedure. So this is outline or highlight of the main issues of standard operating procedure for Walke and Black method for organic carbon. The floor is yours now.
For the preparation of diphenylamine indicator, I don't have phosphoric acid. I prepare it in concentrated sulfuric acid.
It is okay, yes.
It's okay.
Yeah, phosphoric acid to remove the impact of ferrous.
Okay.
Yeah. If you are ready, we can go to practical part prepared from your side, and then we come again to discussion. What do you think?
We have to ask the other. I'm ready. I made a video yesterday.
Yes, yeah, I just.
Yes. So whenever you want, I can share my screen for the videos. It's actually two. One before the 30 minutes of wait, the other after. So we don't waste time today in waiting 30 minutes.
Okay.
Dr. Talal said it's okay. I don't know about the others.
For me, it's okay too. We are ready to see.
Okay, no problem.
Yeah, 1 second. So I will share my screen. Can you see my screen?
Yes.
Okay. Okay. إعلان غلطنا. Wait for 30 minutes. Okay, that's the first part. مش مبين. So that was the video I prepared yesterday.
ممتاز، عمل ممتاز.
Thank you.
Welcome.
فالوري، وقت اللي زدت الان اف هلا ما كان مبين قد ايه زدتي بالملعقه، كانت كميه كبيره ولا كميه صغيره؟
لا تقريبا نص ملعقة.
لانه انا عم بستعمل سبون كثير كثير صغيره.
نص ملعقة بحد تقريبا. هلا هو حسب الاس او بي تبع دكتور ضفله منهم قايلين انه بينحط ان اف.
نحن عم نحطه بدل الاشتراك او كاتر.
عم نحط
ما عندنا اشتراك او كاتر، عم نحط ان اف.
اما هو بدي اتاكد من دكتور ضفله انا انه instead of phosphoric acid we are using H2SO4 for the diphenylamine and the sodium fluoride.
هو الاسيد الهدف منه الفسفوريك اسيد الهدف منه لتقليل الحديد.
والصوديوم فلورايد لشو استعماله؟ فينا نغض ما نستعمله؟
صوديوم وات؟
صوديوم فلورايد NaF. The sodium fluoride, after the 30 minutes of waiting, we add 100 milliliter of distilled water
NF للكلورايد بتتخلصوا منه للكلورايد.
فينا ما نستعمله.
ايوه اذا عندكم الكلورايد بتاعكم ما كتير ممكن، لكن هو زي بيستخدم هناك بديل
الاحتياط.
ايوه بديل لو بتتذكروا في الميثودولوجي لانك الكلورايد بتتخلص منه
هيدا H2SO4.
ايوه بالضبط. نترات الفضه، فهنا ال NAF هنا بس كبديل للكلورايد يعني.
اوكي، يعني فينا نستعمل كميه صغيره حتى ايفن اقل من نص سباتول.
يس.
اوكي، لانه هلا صار ممنوع يفوت على لبنان كمان الصوديوم فلورايد.
ما معناه بس اصلا هو ده ما من ضمن هو بس لتقليل اثر الكلورايد بشكل اساسي.
اوكي.
بس عندي سؤال.
تفضلي
دكتور محمد، إذا وزنت 1 جرام من السويل أول شيء حطيت 10 ml من بوتاسيوم ديكروميت طلع عندي اللون جرين أول شيء، بوزن ساعتها 0.5 جرام؟ معناها
تنقص الوزن، ما تاخدي 1 جرام.
بعمل 0.5 جرام.
أيوه بالضبط، تنقص
معناتها بده يطلع عندي الماتيريال أورجانيك عالي بهالحالة.
بالضبط. بتنقص وزن التربة المستخدمة من 1 جرام ممكن تمشي ل 0.5 جرام.
اوكي ميرسي دكتور.
في فيديو تبع GSP برضو بيعمل الاورجانيك كاربون، ممكن نشوفه لانه برضو فوق ممكن نشاهده وبرضو لانه فوق الميثودولوجي بتاعت
Hello, I am Sumitra Watana, the Director of Office of Science for Land Development, OSLD.
خاصة في الأوتو بنشيوميتر والمانيوال أوتو بنشيوميتر فوقه.
Cooperative Thailand. Our office have 6 fields of soil quality testing laboratories, which are soil chemistry, soil physics, soil mineralogy, plant analysis, fertilizer, and soil environment, all for recommendations and improvement of soil fertility. Services are for all stakeholders, farmers, researchers, private sector, and university. It is a pleasure for our laboratory to host the tuning of this video to show you how to determine soil organic carbon using Worley and RAB titration method. Organic carbon is one of the most important soil parameters. Determining its quantity in soils permits to derive many information, especially on soil fertility, soil biodiversity, soil erosion, and soil buffer capacity for hazardous chemicals. In this video, we will show you how to quantify soil organic carbon using Worley black titration method. This protocol allows you to determine oxidizable organic carbon content in soil, calculated from the amount of chromic ion formed during the reaction. Anyway, The method described here does not routinely apply correction for chloride, which will produce a positive interference rated. This standard operating procedure is based on the Walkley and Black chromic acid wet oxidation method. Basically, oxidizable organic carbon in the soil is oxidized by 0.167 molar potassium dichromate solution in concentrated sulfuric acid. Temperature needed to induce substantial oxidation is raised by the heat of reaction. The dichromate reduced during the reaction with soil is proportional to the oxidizable organic carbon present in the sample. The organic carbon can then be estimated by measuring the remaining unreduced dichromate by backtitrating with ferrous sulfate or ammonium ferrous sulfate using diphenylamine or phenanthroline ferrous complex as an indicator. Regarding this procedure, some points might be noted. Walkley and Black found that on the average about 77% of the organic carbon was recovered by the heat of dilution procedure, and a correction factor of 1.3 be used to account for unrecovered organic carbon. For soils with high organic content, Walkley method may underestimate the result of the organic carbon in the sample. Therefore, in case of samples with very high carbon content, smaller sample weights should be used. This method is for the determination of organic carbon in soils. It is not applicable to soils containing significant amounts of carbonized materials. This method is subject to interferences by certain soil constituents that lead to false results in certain type of soils. The oxide of manganese have been shown to undergo oxidation reduction reactions in chromic acid mixtures, leading to incorrect values for organic carbon. In case of soils with high concentrations of such constituents, we recommend to add phosphoric acid after the sample has been cooled in order to eliminate interferences from the ferric ion. Wash soil sample free of chloride before analyzing, or precipitate the chloride as silver chloride by addition of silver sulfate to the digestion acid. Be aware that this procedure involves the use of hazardous chemicals. Please take note of following safety and hygiene measures. Refer to laboratory safety guidelines and material safety data sheets before proceeding. Be sure to wash hands and clean other exposed areas with mild soap and water after using all chemical reagents. All titrations and handling of chemicals to be undertaken in a full hood. When handling any chemicals, remember to wear safety glasses, gloves, lab coats. Remark for some specific elements. Potassium dichromate is an inorganic compound that emits toxic chromium fumes upon heating. It is a non-human carcinogen and it is associated with an increased risk of developing lung cancer. Sulfuric acid must be kept away from naked flames or heat. Remember to measure the concentration in the air regularly and to carry out operations in a full hood with exhaust or ventilation. Do not discharge the waste into the drain. Keep in mind, never dilute by pouring water into the acid. Always add the acid to the water. Samples should be air dry and sealed. With distilled water, then standardize this reagent daily by titrating it against 10 milliliter of 0.167 molar potassium dichromate after preparing necessary reagents. Now, we are ready to start our procedure using the titration method. Weigh 1 gram of air dye soil into a 250
You hear it now?
aluminum vase or
Yes, Yes, now we can hear it.
10 milliliter of 0.167 molar potassium dichromate and swirl the fast gently to disappear the soil into the solution. Then, with care, rapidly add 20 milliliter concentrated sulfuric acid, directing the stream into the suspension. Immediately swirl the flask gently until the soil and reagent are mixed. Then move vigorously for a total of 1 minute. To minimize heat loss, allow the flask to stand for 30 minutes in a fume hood. Then add 100 milliliter of water into the flask. If proceed the titration by manual method, add 3 to 4 drops of phenolphthalein indicator and titrate the solution with 0.5 molar ferrous sulfate solution. At the endpoint is approached. Proceed the further in titration when using phenolphthalein indicator. The solution take on a greenish cash and then change to a dark green. At this point, add the ferrous sulfate heptahydrate drop by drop until the color changes sharply from blue to red. Maroon color in reflected light against a white background. Determine 1 to 3 blanks in the same manner, but without soil, to standardize the potassium dichromate. In case you proceed by manual potentiometric titration. First, set an expand scale pH meter with a platinum electrode and caramel reference electrode to read the potential difference in millivolt. Insert the electrodes and temperature compensator in the solution and stir with a magnetic stirrer. Tall form beakers can be used as an alternative to conical flasks, giving more room for the electrode, temperature compensator, and burette. Plot a titration curve by recording a value of measured potential difference in millivolt and milliliter titrant 0.5 normal ferrous sulfate added from a burette. The endpoint is then found on the point of inflections on the curve, approximately 750 millivolts. Titration are simply discontinued when this point is reached, and the corresponding titrant consumption is then mature. During the titration, if over 8 milliliter of the 10 milliliter of dichromate has been reduced, the determination must be repeated with a smaller amount of soil sample. From the display equation, we can access that 1 milliliter of 1 normal dichromate solution is equivalent to 3 milligrams of carbon. After the reaction, the excess of dichromate is titrated with 0.5 molar ferrous sulfate or 0.5 ammonium ferrous sulfate as the display equation shows. For accuracy, we participate in an inter-laboratory proficiency test at least once a year. The PTC score should be less than 2. If not, identify root cause, develop corrective and preventive actions, and address the problem. Perform replicate analysis of the certified reference material. Compare results of own laboratory with results of other laboratories as provided in the performance analysis report or certified reference material certificate. The old laboratory result is considered accurate when it falls within the reported 95% confidence. For the precision, perform replicate analysis of 10% of samples in a test batch. Calculate the percent relative standard deviation using the discrete equation to determine if the precision agent. Compare result with the target precision for the analyte concentration as indicated in the display table, which shows expected precision as a function of analyte concentration. Analyze at least one duplicate of the checked samples or internal reference material in every batch analysis. Plot the result in the control chart. Monitor for the results that are outside of the specific limits. Identify the root causes and develop the corrective and preventive actions.
Very nice video.
Yes, I have a question concerning the moisture correction factor. In the formula, they use it to have the percentage of organic carbon.
This by moisture correction factor is related to identify the moisture content of the soil itself. Yes. They're dry.
So we have to analyze the moisture of the soil before doing this analysis.
Yes, yes.
And even for the phosphorus also, I check they need this factor also.
Yes, yes.
Oh, okay. So it's a new parameter. We have to check.
Yes. The air dry.
Okay.
That's the hygroscopic water. You leave only the hygroscopic water because the other water is come easily from the air. You can get moisture, so you have to work on air dry base.
Okay.
But it is very nice that manual potentiometer and this instrument.
Yeah, but we don't have it. I don't know if in another station they have the potentiometer.
Mm-hmm. Normally now there are some studies to correlate between wet digestion and a dry combustion, because the dry combustion is more it is not expensive.
Yes, it only needs electricity.
Yeah, and fairness, and every laboratory has a fairness. So you just put the sample, you weight it. Very nice, very good. Then you put it in a furnace, and the loss of in weight is can be accounted to be the organic matter.
I guess that's what they do for the fertilizers.
So,
but we will have a loss with the temperature.
Even there some yeah. In general, in our cases, in our countries, we have to look for methodologies and procedures that are not expensive and can be handled easily. Especially,
yeah, yes, but now here in Lebanon with the electricity problem, It's not good to do this method, the dry one, if we
As
don't
is
have
the
electricity on the furnace overnight, because it's overnight, right?
Yes, yes, yes.
Yes.
Is that electricity, is that chronic in Lebanon? I thought that it is not a big problem, but from...
No, we don't have electricity. It's the generators. And the generators cut off from 12 midnight till the next morning, or sometimes from the afternoon at the stations here, because we don't have diesels.
It's a big problem.
This is true.
It is new one, or it is just because
No,
of
this is a chronic in Lebanon, chronic. And now it is more acute problem.
احنا بسور ما في عنا جنريتر، ما في كهرباء ابدا.
Yes, it make a big problem for laboratories.
Yeah, that's why it's good if we have the solar panels for the electricity in our stations.
Yes, you remember that you put this in the report.
You suggest this change.
Yeah, we put this in the report so that we're expecting that some support in, especially in infrastructure, could be solar.
We hope.
Yeah. But now I think that there is a lot of concern about soil organic carbon. So there will be a lot of support in, especially for soil laboratories to determine the soil organic carbon in countries, and it will be not only a regional. I think it even global. And this mapping for global soil organic carbon is has been a big issue. You know, this is related to the climate change, and which is now a real problem. In a comment, or we have to plan for the tomorrow. Tomorrow it is phosphorus and nitrogen. Larry.
Yes.
The coordinator.
No, no.
And Maria. What about tomorrow? That nitrogen and phosphorus. Phosphorus is easy. What do you think?
Yes, you are following the agenda, no? The program.
Tomorrow will be phosphorus and nitrogen, the practical part.
Ah, the practical part. So
we have to organize for it for tomorrow.
The ladies must prepare.
الصبايا لازم يجتهدوا معنا شوية بكرة برضه.
The men are not actively participating, yeah?
Yes, it's
Yeah, but I'm participating. I just made a video for the organic carbon.
Okay.
And Marie made the soluble sulfate today. I don't do the total nitrogen in Fanar, so I
yes,
cannot
I know.
do a demonstrative tomorrow.
Falari.
Yes.
Falari has excuse because there is no fume hood, so there is no way for her. But if you like, we can look for videos if there are videos. Maybe it can be helpful. But in general, phosphoric is not difficult. There is spectrometer and this development of color by ammonium molybdate and so on. If you are used to working on it, can be easy. I really like or prefer to have videos from Lebanon, not try to find one in the internet and others, so that we can feel some.
I'll try to prepare for the available phosphorus by the Olson.
Yes.
But as I check in the it's not the vanadat that I use.
What methodology you use?
The molybdat.
Yeah, it is molybdate. Yes.
Yes, the molybdat and the antimony potassium tartrate. That's
yes.
okay. I
yes.
guess we all at Lari we use this method.
Yeah,
with the acid ascorbic and عبير.
وي سوري نحن فالوري ما عم نعمل
ما بتعملوا فوسفات.
ما عم نعمل، معنا اصلا سبيكترو.
اوكي.
والنيتروجين كمان ما عم نعمل.
عبد القادر كرمال الفوسفور. ما حدا عم بيرد.
سوري انا نوجي هلا جيت عم بستلم عينات بعتذر.
يعطيك العافيه. انا سبقتني. ايه ماري للفوسفور.
احنا بالدكتور بنعمل الفوسفور بس ما بعرف اذا رح يكون في كهرباء.
فيك تصوريهم تصوير مثل ما عملت عبير او لانه عندي اجاني 21 عينه. لما ضيع اقعد صور انا اليوم.
بنشوف بكره، لا بكره الصبح بنشوف اذا قدرنا نصوره ونبعته نحن البرزنتيشن.
يعني في اتكل عليكم.
بدي اشوف الجروب اذا رح تزبط معنا بكره او لا. لانه عندنا
الاكستراكشن سوليوشن بيكون صوديوم بايكربونات يا
يس
وبعدك امونيوم موليبديت.
نحن بصور بنشتغل على يو بي اس، اذا مشان اليو بي اس بنشتغل، يعني ما فينا حتى نعمل شيكينج ولا
شيء. اوكي
احنا ما عندنا جنريتور، ما عندنا شيء بصور، بس بنتكل على اليو بي اس يشتغل من كثافه الدوله ساعه بالنهار.
اوكي
بنشوف.
لا انا على بكره عندي فوسفور شغل، بس ما بعرف اذا حيساقي بالوقت، وعندي كثير عينات في 25 يعني الران كبير شوي. يعني بدها تاخذ وقت، بركي بترك اذا في حال ما قدروا صوروا بركي بترك الستاندرد مع عينه بنرجع نقراها ونشوفها وما بعرف.
نحن حنحاول قد ما فينا نحن نعمل.
تمام. احنا طبعا الماتيريال دي ممكن نستفيد منها في بعض الدول مثلا ما بيكون عندهم امكانيات، فبالتالي لما نلقوا فيديوهات مصوره للنظري ده بيساعدهم، خاصه يعني دول مثلا ما يكون عندها امكانيات حتى اللي عندكم دي، يعني ده الشير الامكانيات يعني. النيتروجين هحاول اشوف لو في فيديو، لانه النيتروجين محتاج لبيوم هود وكده، ممكن نعتمد نشوف واحد من الفيديوهات اللي ممكن تكون موجوده في
نحن بصور ما بنعمل
نيتروجين. خلاص هحاول اشوف واحد يكون فيديو بالكواليتي بتاعته كويسه، وان شاء الله انا اي كومنت اي.
لا ثانك يو، انا من جهتي كله تمام.
ثانك يو دكتور.
الله يبارك فيك. طبعا شكر كثير جدا لماريا ولعبير ولفيلاري لانه make this day session successful بالcontribution بتاعهم في تجهيز الجزء العملي. يعني مجهود كبير يعني. شكرا جزيلا.
You're welcome.
واجباتنا.
Indeed, the ladies are doing well, very well.
ولو لو مش مضغوطين كمان بالسامبلز كان فينا
And you
نكون
know-
اكتف اكثر.
You know
نحن
that
عم نشتغل عيناتنا بوقت عم نحضر كمان البراكتس فهذا اونلاين فعن جد
ايه وهلا
بدنا قادرين يعني نعطي وقت اكثر. يا ريت قادرين نعطيه وقت اكثر لو ما عندنا شغل بس.
وهلا
you
كل العالم
know that today is your day. It is international Women's Day.
ليلة يوم المرأة يعني.
يوم المرأة العالمي. So thank you very much for your effort.
Thank you guys.
You are making our days. Thank you ladies.
Thank you دكتور.
الليلة يوم الصبايا يعني. حسموه يوم الصبايا في لبنان ولا يوم المرأة؟
يوم المرأة.
ها؟
يوم المرأة العالمي مش بس بلبنان.
لا ما أنا عارف يوم المرأة العالمي لكن قصدي يعني أنتوا في لبنان بتستخدموا لفظ صبايا أكثر.
صبايا للعزابة مش للمتزوجات.
يعني كل سنة وأنتم طيبين بمناسبة يوم المرأة يعني.
شكرا.
النساء وشقائق الرجال. طيب إذا ما في حاجة نلتقي غدا إن شاء الله. أنا طبعا أنا سعيد جدا بالتريننج ده يعني.
ونحن كمان.
نحن كمان دكتور.
يعني
ثانك يو لك. عم ناخذ من وقتك نحن.
لا ده ما زي ما بقولوا ما بليجر يعني.
ثانك يو.
طيب أتمنى لكم يوم سعيد بمناسبة يوم المرأة وربنا يقدركم على يقدر الصبايا على باقي العينات السامبل الموجودة قدامه.
شكرا.
الله يبارك. نلتقي غدا إن شاء الله.
الله راضي.
See you tomorrow. Bye. Thank you.
باي. السلام عليكم.
السلام عليكم.